Recording. Okay, so this is our first controls presentation for Spectrum this season. We're going to start not with specific robot stuff yet. We're just going to get straight into kind of some basic introduction to programming and the Java programming language. The very first program we're going to look at is written out. So if on your presentation, if you click this link, we're going to go to what's called JDoodle. And it lets us do kind of investigate and explore the code straight in our browser. So we won't have to, so you don't have to download anything. You can run everything right here. We're going to kind of explain what all of this is.
Is JDoodle specifically, does it work specifically for the robot
No, Luke,
functions?
it does. No, it does not. We're just learning Java for right now. So if you have questions during this one, as much as you can, try to use the chat and not interrupt, because otherwise it's going to take way too long.
Okay.
Okay, so coming back to it. So so as everyone pulls up this first program, the way JDoodle kind of works, you can just click the execute button down here and it'll actually run whatever code you have typed here. So it'll give us our answer, which is 30 from our very simple math problem that we have this program do. Okay, so we're gonna go kind of look at part of what this program actually does and how we lay it all out. So the very first thing you kind of notice when you're looking at the program is there's a bunch of green text, and that's just how JDoodle lets us know what our comments are. And comments are anything that we don't want the program to think of as like instructions, right? So these are just for us humans when we're reading it to understand what the code is actually doing, what the program is actually doing, and not for the computer to understand how to do something. So anything that is a comment is completely ignored by the computer when it's trying to run the program. So it just ignores it. It doesn't even know it exists. So for Java, the way you can tell if something is a comment, the line will either start with 2 slashes, or it'll be between a slash star and a star slash. So if you want a single line, you can just do the 2 slashes. If something's going to be like a bigger block of text, like if you're going to write out a paragraph, use the slash star to do that. Comments are really important. It is very easy to, one, sometimes forget what you intended for code to do. So if you don't know why you wrote something because you wrote it maybe a few months ago or even yesterday and you weren't quite sure what happened, the comments are there to kind of explain it. But more importantly than that is when somebody else comes to look at your program, you want them to understand the intent of your program, right? Maybe what you actually wrote doesn't quite do what you want it to do, but if your comment is correct, they may be able to help fix it a little bit easier. And especially when we're programming as a team, it's very important to leave comments so that someone else can go through and make sure the code's actually doing what we intend it to do. Okay. The next part of the program that we're going to talk about, so all of this stuff in green is our comments. The next part of the program, we're going to skip down to this section right here, and we're going to talk about variables. So variables are used to store information. There's similar idea to variables like you would have in math class, in algebra or anything like that, but they're a little bit different. So variables in computer science and in programming basically allow us to store information and then act on that information in different ways. So we can change the value that's stored somewhere, or we can retrieve it and use it to either assign a new value or do something in our program. Variables all have names. So in this case, some of the variable names are x, y, and answer. All 3 of those are variables. You want the name to be easily identifiable. So you want it to be descriptive of kind of what value it's going to hold. In this case, they're just kind of math problems. So x and y and answer are relatively descriptive for what we need it to do. As we start getting to more robot-specific stuff, we'll have longer, more descriptive variable names. There are different types of variables, and variable types are pretty important. The 3 variables in the beginning in this program are all of type int. Int is short for integer, so the full variable type is an integer, and it's basically a type of it basically tells the computer this variable is going to store whole numbers. So you can put 0, 1, 2, 3, 4, 5, 6, 7. It can store negative numbers, negative 1, 2, 3, 4, 5, 6, 7. But it can't store 1.5 or 1.2. It can only store whole numbers in an integer. They can't hold any decimal points. As you're looking through so variables, it depends on the type for what type of what instance. So someone asked if they could hold like a space. Variable names can't have spaces. So you can only have whole words, but you can use underscores and other things if you needed to make something slightly spaced. And we'll look at more examples of how you name variables, and there's some conventions as well later. Okay, as we look through this code, each of the lines kind of ends with a semicolon. So at least each of these 4 lines do. And in Java, basically everything that is a statement has to end with a semicolon. So that's basically things that we want the program to do. So those are what we call statements. And so if you forget a semicolon, if we were to go ahead and like delete one here, we can see the example, and Java will get will give us an error. So it will most of the time it'll kind of tell you what that error was. So here, highlighting does not make it better. Error semicolon expected int x equals 10, and even points out exactly where it expected it. So it tells you, okay, I should have had a semicolon here. I didn't. Let me try again. And now the code works. So you may have issues where sometimes you forget one, but normally when you go to try to run your code, it will let you know. Okay, so one of the things we can do with programming is basic math. It's one of the easiest things to introduce because we all know basic math, right? We all can add, subtract, multiply, divide. But it is a little bit different sometimes than what we do exactly in algebra. We use some of the same concepts, but things are a little bit different. So one of the first things to think about is the equal sign in programming is what's known as the assignment operator. So it's not necessarily equals as you would do in math, where you know for sure everything on the left is equal to everything on the right. In this case, we're actually forcing everything on the left to be equal to whatever is on the right. So x equals 10 means that no matter what x used to be, x is now 10. So that's not necessarily true in math, right? If you had somewhere else where you would have a variable or something and you would assign it, you would almost be like checking if these were equal, or you'd find a way to make them equal. Here, the forcing is happening no matter what with the equal sign. So for example, 10 equals x wouldn't work because we don't know what x necessarily is. X could be something from before, and you can't assign a new value to 10, right? 10 has a factual value to it. We know 10 is a thing. It is a number. We can't assign a new value to 10. So you always want to make sure you're writing it in the correct order. X equals 10 is correct. 10 equals x is not. In this program, we're clearly just adding x and y, but we have other operators we can use too. So subtract is just the minus. Multiply uses the star or asterisk, shift 8 on your keyboard. And divide uses the slash. So those are all called operators, is what they're called in programming. We're going to go ahead and, oh, not yet. In a second, we're going to go and do some of them. The last thing to look at before we kind of look at the program is how we actually get our output. So this final line does a little bit more complex things, right? These are relatively easy to understand. We have a variable, a type. We set it equal to 10. This last thing does a little bit more. So this is System.out.println, and that ln is short for line. So we normally shorten all of this to just call it print line. And so this specific thing is called a method. Not this specific one, but anything where you have these kind of parentheses it's called a method, and it's how you can tell the system to do a much more complicated action. So there's something like, there's a bunch of code and program behind it that you don't necessarily need to see, but you just know it's going to do something for you that's able to be run as soon as you call what's called the method. So you type it and you have it run this specific thing, in this case println, and it'll do something for you. They're often called functions in other programming language. In Java, they're called methods. If you interchange them, it's not a big deal. We can send variables to methods. So if we put things inside the parentheses, it allows whatever the method is to use that information and then do something with it. So in this specific case, println lets us output text for us to actually read. So whatever is in the parentheses, it will display, in this case, down in the black box. Part of what we're doing here is we're telling our program what is text. So things in quote are text for us. So this answer colon space, it's going to specifically type that out. And then we also have a plus sign, which is how we can like add something together. So it's instead of like adding in the math sense where you would, 5 + 5 = 10, this is basically combining. So this is almost like a and symbol or something. So it's the answer colon space, and then in addition, print whatever answer is. So since answer here is not in quotes, it's referring to the variable. So it's going to give us whatever answer is, and it's going to put it inside of this print line, and then all of it is going to be sent down here. So that's why when we hit execute, the output is answer colon space 30, because at this point in the program, answer is equal to 30 after it solved x plus y. Okay, so now that we understand a little bit about how it's working, take a few minutes. We'll come back at like 4:22, so you have like 4 minutes, and just modify the program. So you can go in and change the variables and make sure that they do what you expect. You can change the operator. Okay, let me finish the instructions real fast. And then you can change any of like the text in here and make sure it's outputting the text properly. Or if you can modify other things that you think can modify, and if you execute it, it may either give you an error or it may give you the result you expect. Okay, what's your question, Luke?
So I saw that all the code is in a class, and
we're gonna get there. We're not ready for that yet.
I'm just wondering, could you put the code not in that class?
We're not, say, Luke, we're not ready for classes or anything yet. Like intentionally we don't jump ahead right now because there's a lot of people in this lesson and they're not ready for that answer or anything yet. So like we will eventually answer that, but it is not the time.
Will you answer that today?
We can if you want to wait till after, but it doesn't. Going through it right now just causes way more confusion than it helps.
Okay.
Because we haven't even explained what a class is yet.
Quick question. I changed the 10 to, and I added a bunch of zeros at the end, and it said the number's too large. What's the maximum number you can add?
I think it might be 32,000 something.
Luke is correct. There is a max number you can add on an integer, and we'll talk about bigger numbers in a little bit. We'll actually get there shortly. But yeah, there is a maximum number you can add to an integer. It's basically how much the computer can store in any one variable based on the type. An integer is a relatively small number type compared to very, very big numbers that you can do in other number types.
And does everybody on the FRC competition use Java?
No, not necessarily.
No.
Our team does, but not necessarily. There's C++, there's LabVIEW, there's a few teams who program in Python, but it's unsupported. There's a couple other programming languages teams could use.
Okay. Why did we choose Java?
It's what the AP classes teach, so our schools teach it in both Agnes and Strake, so that's one of the advantages we have. It's also the most widely used one by far, so there's way more examples and there's more teams who use it than anything else.
Okay. And what do we use to run these programs?
We are not there yet. We
Okay.
will get there. If anyone, yeah, for stuff like that, if you want to read ahead, you can go into the Google Classroom. There's stuff already produced. There's links for further self-learning. You can go through all of that, but it's not time to introduce all of that yet.
I have a question.
Sure.
For an answer, I put equals x plus y, and then times x and times y a bunch of times. I got a negative number somehow.
That can be possible. So so the variables are, like we said, they're small enough that you get what's called rollover. So if you get to too big, it flips over to the negative side, basically. And that'll come later when we're dealing with the large numbers. Most times you won't run into that problem in actual programs because we don't use integers for very many things. This is just the easiest way to get started as an example.
Okay.
But yeah, so you will get, I'm trying to think how to best, like if you could imagine like there's just like a big dial of numbers, right? And each one you had like a big circle 0 through 9.
Yeah,
if
I
you
understand.
eventually rolled, if you just went all the way up and eventually rolled over, you get to like the other side, and the other side is negative, basically. That's roughly what happened. Okay, so if we've had some time to kind of play with it, we had a couple good questions come out of that. Thank you. So one of the things that hopefully a few of you saw was that if you do division, so the kind of simple switch here and just tell it x divided by y, your answer is going to be a little bit different, and because we should have already realized this. So 10 divided by 20, we all know should be 1/2, but specifically because we are on integers and we only have whole numbers, we get 0 instead of 0.5, right? So we would expect if the true answer, if we were doing this in a math class, we would get 0.5, but because we're an integer, it can't hold any decimal values, so we get 0. So that is an important thing to realize if you are using a integer or any variable that can only hold whole numbers, and you end up trying to get a decimal, it's going to truncate it. So it's not even going to round it, right? Because we could do other things. We could try like 15 divided by 20. And if we rounded that, it would be 1, but it's not even rounding. It's just taking any of the decimals and acting as if they're not there.
So I know in programming languages, in some of them, you have to have a certain number of tabs. Does that matter in Java?
It does not.
Okay, so
That is why, yeah, that's why we have that. That's a good question. That's why you have the semicolons. So you can do some very ugly programming if we wanted to. So if we wanted to get rid of all of this, we could do even weirder things. You can do like that, and all of that should still execute. We wouldn't want to because it's really hard to read. And now I've made my code ugly. Okay, I'm gonna go back and type some things. Okay. Tab behind. So yeah, so your tabs don't matter, but they matter in terms of readability though. So trying to make your code look like nice and easy to understand is useful. But to the actual program, it doesn't notice. Okay, so to solve a bunch of the problems we've run into, so to solve the problem of our numbers being able to like put too small or too large of numbers in there and having errors, or having decimal points, we can switch our variable type to double. So instead of int, we're going to type double everywhere. And that little change, if I delete properly, that little change is going to make our code do some different things. So now I can change this back to 10, so the example stays the same. Now when we execute and we have doubles, we now get 0.5 because a double is able to store decimal values. It's also able to hold much larger values. So if you mess around and put more zeros, you should be able to get quite a few more zeros into a double than you could an integer. Okay. Another variable type, a string in Java is like a variable that stores text. It's a little bit more complicated than that, but for now, just think of it like a variable that stores text. So if we didn't want to type out answer here, we could do it in a string variable. So we could call it like text, and then we could copy over this part and hit paste, and text, and I forgot the semicolon, so I'm going to add it back. So we put the semicolon there, and so now it's going to, this should give us a very similar answer to what we already got, but instead of typing out our text here, we can store it inside of our text string. Yep, we get the same thing.
You can also use longs if you need a big number, but you don't.
Luke, please don't introduce things that aren't in the slide deck. I promise I have thought about what I'm introducing and when, and it is all useful and important for what we're doing. Okay. Any questions about our first program that we've gone through? Okay. So the next slide should have the second program to load. So if you click this link, you should bring up a new JDoodle with a new program for you. It's a little more complicated, it's a little longer, and it uses a lot of the same things we've talked about, but it does use some new things as well that we're going to go over. All right, so the first time that we run this program, we get all of these statements here, right? Because we have, instead of just having that one print line statement, that one System.out.println, we now have 6 print lines. So we have a print line here, 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 and the 3 more down here. So each one of these is printing out the answer to some of these, like what are called Boolean statements. And these are down here are called comparisons. So we're going to go through the top section first and talk about what a Boolean is, and kind of what some of this Boolean logic does. Okay, so actually the first thing, you can actually go ahead and play around with it for a bit. So if you do some of these things, if we change the value of B2, we're going to change kind of the outputs here. If you change the value of B1, so your 2 options here are true or false. Those are your only 2 options for B1 or B2. And you can see how they change. If you change them to both true, if you change B1 to false and B2 to true, you can kind of see the different outputs. And you can also change the values of X and Y and see how those outputs change down at the bottom as well. Oh man, all over the place. All right, one more minute and then we'll move on. So looking at Boolean logic, so Booleans are another type of variable. You can see because they're in pink here, just like the int was or anything like that. So they're like keyword specific, and they kind of start this variable definition, this kind of same formula that we had before, right? We used to have int x equals 10. Now we have Boolean b1 equals true. So it's that same type of, that same pattern exists here. So we kind of know that this is a variable assignment. The values for Booleans can be true or false. Make sure you use lowercase. In Java, they're lowercase true and false. What we have are what's called logic operators, and those let us act on Booleans in specific ways. So the three that we're going to go over are and, which we use as a double ampersand, or the double and symbol. And so that's only going to result in a true statement when both of the values on its left and right are also true. Down here, we have three things that we call truth tables. So the idea is that this is A, B, this is A and B. So if A is false and B is false, A and B is false. If A is true, B is false, A and B is false. And the only one that is true is when A, this little thing won't go away. Whenever A is true and B is true, then A and B are true. Or, which we have as two of what are known as pipes normally, but they're basically just shift slash. So if you do shift slash, you get the or symbol in Java. And so when either value on the left or right is true, or will be true. So here we have these three truth table. We have these three true values. So here we have these three truth values. So anytime any of them are true, A or B is always true. And then not is the final one. So all not is actually a single operator, so it doesn't have a value on its left or right. Not only takes a single value, and it works for it just inverts the value. So if A is false, not A is true. If A is true, not A is false. If you wanted to combine these, you can combine these into, so like happen over multiple operators, you can, kind of like you would do in math. The easiest way is to have parentheses, so you can force which way you want something to work. So if you had parentheses A and B and C, then you know how everything's going to work. If you just did it without, for and, it totally works. For or, it can get a little bit more complicated sometimes, depending on how you do the orders and things, if you combine them with an and or something like that. But yes, you can do it to more cases and combine them to more things. In our code, we have examples of and, or, and not that we can go through and experiment with. And so you can see how they're fully typed out here. You can also see how we had to use some parentheses in a few places. So like basically parentheses work the same way they work in math, where they kind of force something to happen first. If we don't have them, I don't actually know if this throws an error. Yeah, so this would throw an error. So because we got rid of the parentheses here and Java didn't know exactly what to do, it added the B1 to it. So it would have displayed like true here, and then it tried to and this whole statement with B2, and it didn't know how to do that, right? Because it's not just a Boolean. This has text in it. It doesn't really know what's going on. So it gets confused here because it tried to take a string, which is text, and it to a Boolean, and it didn't know how to do that. So those parentheses are really important, just like they are in math, to make sure things happen in the right order, so that the computer can actually follow the code the way we want it to. Okay. The next step is comparisons. So these are very similar to what you would have in math, right? You probably learned these in elementary school: less than, greater than, and equal to. There are also less than equal to and greater than equal to. And there's also not equal to. We're not going to go through specific examples of those. You can kind of figure out what they do based on your understanding of the operators from elementary school and from math, but they're relatively simple. But the most important thing is that these operators give back Boolean values. So x less than y, when x is less than y, gives back a Boolean. So when we have like the output down here, it is either true or false. So then you could go into here and do things like anding this to something else, or oring or not this to something else, and it would work, right? So since this is its full output, if I was to put a not here and kind of tell this whole thing to be a not, it would flip this value, and now this is false, even though x is less than y, because I use that not. So that is an example of how you would have multiple operators kind of acting over multiple times. One of the biggest things to remember is that equals, when you're trying to compare something and find out if something is equals to something else, is it's double equals. So it's not just the equal sign, because we already learned earlier that equals is the assignment operator. So if we don't do the double equals, you get some confusing things, because now if I do x equals y instead of equals y, let me do it down there actually here. Let me delete it. Okay, so if I do this where you do x equals y, instead of false, I now get 20, because instead of checking if x is equal to y, I forced x to be equal to y, right? That's a really big and important difference between x equals y and x equals y, right? One is force x to be equal to y. The other is asking the question, is x equal to y?
I have a really quick question.
Yeah, what's up, Grisha?
So, is there an assignment operator for greater than or less than?
No, because how would that work? Like, you're just like trying to force x to be less than y?
Yeah. So, for instance,
So you could. So the only way to do that would be to write a method or something. There, like a lot of times you could have it like, you could tell it to cap a value at some value or something, but it wouldn't know what value to put there necessarily. Like, it needs a lot more information. So there's no specific assignment operator. But you could make something that did that, right? So you could say, you could make a method, which we'll get to later. We'll go into that. We can actually do that in an example later if we get to it. We don't need to touch that yet, because there's some concepts we haven't introduced yet to do that. But one of the biggest things to take away here is that equals is the assignment operator, double equals is the equals comparison. And if something is just being really wonky in your code and you're not sure why, it's early on, this is definitely one of the things to check, because it happens a lot to people where they do something just like that, where they think they did double equals and instead they did a single one, and now everything in their code just looks funny or doesn't work. Okay, so adding on a little bit more, we have a third program, and this kind of shows you how we use a lot of this now. So it didn't really make sense to just be checking if how these ands and stuff worked, but it's really important when we actually start kind of trying to make our programs actually do things. And one of the easiest ways that we do it a lot with our robot is with if statements. So if statements are similar to basically everything, or similar in most programming languages. And what they let you do is kind of control the flow of your program. So instead of just having the program do every single line that you type out, you have it check something, and if this thing is true or not, then it'll do this line. If it's not true, so if B1 is false, it'll just skip right over it and it won't do it. So that allows your program to do different things based on conditions. So now once we get into eventually when we get into robots, your robot can choose to do something based on if something else is happening or not, right? If the operator has hit a button, or if something has hit a switch somewhere, right? You can change the flow of your program based on conditions in the world, not just have everything run in a specific order. Okay, so you should be able to pull up the third program through that link. We can execute it down here and see what happens. So yeah, so we get a B1 is true. We get a B1 and B2 is false. So it came down here and executed this line. And we get an X less than Y. So even though we have these 6 print statements in our code, only 3 of them actually ran. Right? So the other ones were all skipped over because somehow their conditions weren't met, is what it's called. Okay, so go ahead and take 3 minutes. We'll come back at 4:45. You can modify the different variables here and here and just see and kind of understand what these different things do, right? We should have been able to have some idea of what they're going to do based on the last code. But go ahead and read it, read through the comments, and just get some idea of how everything works. And feel free if you need to change, if you want to change some of the comparisons, go ahead.
Alan.
Yeah.
You may have already answered this, but does true and false need to be capitalized?
No,
or
they need to be
lowercase?
lowercase in Java.
Oh, okay. Thank you.
As far as I know, every Java interpreter is like that. And there might be one that's not, but lowercase is the standard one that I know of.
Okay.
I'm pretty sure.
That is good to know. Thank you.
On line number 8, when it says if in parentheses B1 and then open bracket, B1 without the exclamation mark in front of it is a given that like if B1 equals true, right?
Yeah, because B1 is true here, B1 is true there, right? So it's just,
Okay.
it just takes that replacement. If you change this to false, if B1, this is going to be if false.
Mm-hmm. I'm saying that because the exclamation mark isn't there, it's saying like that if this is true, like if is true, like the words is true is basically hidden in the absence of the exclamation mark in front of B1, right?
So any if statement is always checking if the thing in the parentheses right here is true, right? So it's the same thing here. If B1 and B2 are true, then do this.
Yeah.
That's what it's always doing.
Mhm.
If you had the exclamation point, it's saying if not B1 is true. It's still checking if something is true. The not is just modifying what it's checking.
Mhm.
Okay, let's go through and explain some of the if statements a little bit. The comments do a pretty good job in this program to do it, and we did it with the question a little bit. But basically, like I just said, your if statement is going to check if whatever is in the parentheses is true or not. If it is true, it's going to execute the code that follows. If it's not true, it's going to skip over the code and go to the next line. We can modify that a little bit, and we can extend that a little bit and have what's called an else clause. So in this case, it's going to check if B1 and B2 are true. If they are not true, then it skips over like it does before, and now it runs into this thing called else. And if it hits else, it's going to always run this next line, right? No matter what happens, it doesn't have to check any other case. It's basically just saying, if these aren't true, then do this. If this is true, though, it'll skip over the else clause. So else is only run if one of the if clauses before it isn't run. So we can see that like full extension down here where we have 3 of these. So you get the if statement first, so we check if they're equal. You get the else if we check then it's greater than. And then else, we don't have to check if it's less than because we know that it can only be one of those 3 things, right? Numbers largely, without some sort of weirdness, can only be less than, equal to, or greater than another number, especially an integer. So for us, we don't have to check again. We don't have to put another if. We can just do else because once we've gotten here, we know that x is less than y.
I have a question real quick.
Yep.
Could you possibly use elif instead of else if? Or does that not work?
That does not work in Java, I do not believe. But feel free to try it and see what it executes as. Like, you have the code in front of you. I'm almost certain it errors out. And this is also just more explicit anyway. So we all know what it is. So you can, when you're reading it, it's more explicit to write out the else if anyway. But in other programming languages, you do have a different keyword there. So if x is greater than, so if we swap these two values, just so we have the example right now, we know it's printing out x less than y because that's what it is. If we swap these out, we can see that this line is going to come out as x greater than y, and it's not going to get to this bottom line. All right, so we get x greater than y, and it doesn't print x less than y because once this comes back as true, it knows to just do this line and skip down to the end of this whole statement. Here. Nope, I think those are all pretty good. Okay. This is one of the most important flowcharts that, or like kind of flow tools or programming tools that we use, and especially in the robot, we use this more than we use anything else. There's a bunch of stuff that using types of other programming things, but we just don't use them nearly as much as we use this for robots. Okay, so we still have a little bit of time. I'm gonna try to get through this. Is our fourth program. All right, so our fourth program is going to introduce making our own methods. So before we had all been running in, everything had been running in this kind of like main statement that we had up at the top here. And that's just what Java knows is like the first thing to run. And so everything had been happening inside of there. But now if we want to be able to do slightly more complicated things, especially when we're doing a lot of repeated tasks where we have to do the same thing over and over again, we create our own methods to do that. So we have two different methods that are written out here. One is called add4. That's the method name, is this part right here. It takes in a variable type of a double. So we know that that's a type of number, and we have a name for it. We call it num here. It's just short for number. We could type out number if we wanted to, but the abbreviation is close enough. I think most people would know it's a number if we got to here. And so that is its, that's what basically is allowed to be passed into the method, and the method is going to do something too. I think we have some slides that help explain all of this, so I don't have to do it live. Let me see. I'm not going to spend a bunch of time exploring this one because we're running out of time, so I'm going to try to get through this. So for now, just know that the public static part is something that is needed for this to work well right now. We don't need to go over exactly what those do. We'll get to that in a later session. The next value, this double right here, okay, this double right here is what's called the return type. So this just tells us what are we going to get back when we call add4. So because this is a double, this means we'd be able to get back a number with a decimal point or a pretty large number. If this was a Boolean, we'd know that add4 would like return true or false. That would be really confusing for something like add4 because we expect a number back from a name like that. But you could do it. It would just be confusing to humans. The computer wouldn't care, right? The computer doesn't really know what add4 means. It just knows that that is 7 letters in a row. But it's important to make sure we're naming things that humans can understand when we go back through and read it. If we look down at the second method down here, the if true print method, we have this new word that we haven't really seen very much of. So it's been up here at kind of at the top of our program for a little bit, at the top of our main method, but it's called void. And all this does is basically say, okay, this method that we wrote isn't going to return anything. So we don't expect a value back kind of in our code. So we can't do if true print +4 or something. It does that wouldn't make sense, because if true print doesn't have a value. It's not returning anything, so it doesn't become any value once it runs. Where add4 becomes a value, basically. The computer can think of it as this double where we want to use it in places. So you can return any type. So if we wanted to return a Boolean, or if we wanted to return an integer, we could return a string. All of those things can happen. Okay, so the comments kind of tell you a little bit more about which each one of those do, right? We have very simple number, num +4, so we know we're just adding 4 to that number. This return statement is how we tell the program that this is kind of complete, and this is what we want to replace the method with. This is what we want to, what's called return. So whatever's on the right side of return here is the double that's going to be sent back. If this was a string, we would expect us to have a string written out here in some way, so we could have text here. If this was an int, we would expect to have an int here. And that's why down here we can use it. So in System.out.println add 4, we expect a value, so we know we're going to get a value back here that print is able to send away. So if we execute this, it prints out 14, because that is add 4 to x. X is 10, so it prints out 14. Our second method, if true print, what it does is it takes a Boolean value. So we pass in a Boolean first, and it checks if that Boolean, then it goes ahead and prints. If the Boolean isn't there, it won't. Or if the Boolean is false, it won't print. So here, if true print b1x, it prints out x is 10. If true print not b1, so in this case we're passing in false here, it wouldn't print y. So if we change this to b2, now we get not b2, not false, is true. So now we're passing in true to the if true print method. And so now we'll get this third print statement that is printing 20, because it's printing out y. All the items inside these parentheses are called parameters. So add 4 has one parameter, which is this double. If true print has 2 parameters, it has a Boolean bool and a double num as well. You can also see that your program can use the same names in places sometimes, as long as they're in different methods. So here we have double num and double num, and the program's okay with that because it knows, in this case, because I'm inside of this method, this version of num is referring to this one, and this version of num is referring to this one. If you try to do the same thing down here, it wouldn't work. So if I tried to make Boolean b1 twice, it's going to get mad at me. It's going to send an error, right? Because I already have created a Boolean b1, and I'm kind of trying to do it in the same method. It doesn't know how to do that. Okay, we went through that already. Cool. Okay. We're going to hop through this real fast, and then I'll accept questions. So our fifth program is a little bit more complicated. So this will probably take us another 10 minutes or so, so we'll end a little bit after 5. So now, instead of just adding methods like we did before, we're going to add what's called a class. So real fast, what happens when we execute this, we just get we get our print statements. These are the same things we already knew, right? M1 channel, these are method calls, so we're just going to call methods, and we're going to return whatever the results are, and we're going to print those out for us. Same thing here. And then it's just going to print M1 channel 0, 1, 1.0 and negative 1.0. And we're going to explain kind of how it's getting these methods and getting these answers in the next couple minutes. So the second part of this program is the class that we wrote. So this is a very simple motor class example. This isn't a real one, would have a lot more stuff in it than this. But we can imagine that this is similar to what we would have on our robot to be able to control a motor, to be able to set it to a certain speed, and kind of get values back and interact with something that we were controlling on a robot. So we can move around some of the variable names and how we kind of did things. We can change this 1 and negative 1 and see what we get out. But really the real meat of this is kind of what's happening inside of this class motor that we wrote. And that's what we're going to go through. So, oh, actually we did this backwards. Okay, that's fine. We can do it separate times. Okay, so we're actually going to start up here. So these follow a similar pattern to our variable definitions, right? Before we had like int x equals 10, right? So it's similar pattern, but it's a little bit different because now we have this new keyword that's in pink that we haven't really explored yet. So what that's for is what's called creating an instance of a class. So it's a couple new words we haven't gotten to. But basically, this motor class down here is what we created. So we have this thing called a motor class, and it has some values, it has some variables, it has a int channel, it has a double speed, it has some methods in it, and all of these together are a class. And when we use this new keyword, we're basically making a copy of it. Copy is kind of a strong word. We're making an instance of it. We're saying, okay, now this thing exists in our virtual world. And so M1 now exists. And in M1, it has a channel, it has a speed, and it has these methods. And M2 is an entirely separate, different version of it, right? So it has its own kind of copy of all of those things that exists in our program. And so when you modify them, when you modify M1 and M2, you modify them separately and they don't really talk to each other, right? So they're their own instance of all of these things. And this allows us to really easy copy a lot of code and like implement it very quickly without having to rewrite a lot of things, right? Because you can imagine if we had to write all of the code for every motor that we had, it would be really, really long and complicated. But instead, we can write all of the code once and create multiple instances of it as we go. So yeah, one of the big takeaways is that each object is a new instance of the class and they keep their own values. And that's the really important part, is they all have their own values for the different variables and they have their own methods that are acting on those variables. When we need to call a method from a class, we use the pattern of the instance. So here M1 is that the name of this instance, right? We made it up here. And then we do dot get the method, or dot the method name. So in this case, get channel is one of the methods in the class. So similar to how we had a add for before, right? But we could do that without putting anything in front of it because it was a method just kind of already in our main program, or is already in the same class that we were in. Because this is its own class, we have to tell it what instance it is. So m1.getChannel. And a lot of what you're just picking up here, you don't need to know how to do all of this. We kind of just want to know kind of what the patterns are. That's what we're trying to learn right now. You won't be asked to just like make a class out of nowhere right now. It's more that you're able to kind of use them and figure out, okay, I have this instance of M1. I can now do m1.getSpeed or m1.setSpeed, and I kind of know what that means. That's all we're asking you to know right now. Okay. When we make our own class, it's very simple for right now. We just have to tell it it's a class. So we use this class, we use the class keyword. We give it a name, in this case, motor. And then we use these braces to kind of define everything that's going to be inside the class. one of the unique things about a class is they have this special method right here. This method is called the constructor. So this method does not have a return type, which is the most important part of it. So it kind of defines it as a constructor. So instead of having int or double or void or anything, it just doesn't have, it has nothing. So it just sits here like that. And it has the same name as the class. So that's really important. So that's how the programming language knows that it's the constructor, is it has the same name as the class. And so what this does is whenever we call this new motor 0, right, this calls the constructor. So when we do m1 equals new motor 0, we're going to call this method here. And since we have 0 as the parameter, channel equals 0, or channel equals C as in here, so it's going to be channel equals 0. So then when we do m1.getChannel, our output is 0, because that's how the constructor assigned that variable. Like we already talked about, a class has its own methods. One of the kind of simple examples of things that we do a lot in classes on the robot are what we call getter and setter methods. So a getter method is just something that returns a variable from the class. So here, get channel just returns the channel variable. Get speed just returns the speed variable. And a setter method is very simple. All it does is set a variable for the class. So set speed is just going to assign speed equal to whatever value we pass in. You would definitely have more complicated methods in some of your classes, but these ones are very commonplace as well, so that we can interact with classes in this kind of manner. Okay. Any questions about those last two things? Again, you're not supposed to be able to just like write your own or anything for these by any means. This is just supposed to introduce the idea, and then the next time we talk about programming, which will be in 2 weeks, I believe, we'll be able to show you kind of how we use these on the robots more. And even then, you're still not writing your own classes for a while. We're just interacting with ones that exist.
Do we have to take the quiz, or is that optional?
It's the quiz is preferred if you can. If you want to be kind of following along the entire time we're doing controls training, the more you can do the quizzes, the more it helps me to know what everyone actually remembers and got out of it, and I can add more to the next lessons and things if I need to.
Okay.
They're all super short. It will take you less than 10 minutes.
Okay.
Other questions?
What's the difference between get speed and set speed?
Sure. So get speed is a getter method, right? So it's going to return the value. So whenever you do get speed in your code, it gets replaced by whatever the value that's already stored in the class, right? So at the beginning, speed is equal to 0. But before we actually print these lines, we call set speed, and that's going to change the value, right? Because we pass in this 1 for the M1. So we pass in 1. 1's going to get assigned to speed. And so now when we call m1.getSpeed, down here it outputs a 1 instead of the 0 that it was before. So if we like comment this out, so if by commenting something out, you kind of just do this double slash, it becomes green, so we know it's commented. And then if I execute, since I never set it, M1 speed is just 0 now. Does that make sense? Any other questions? Okay, I'm gonna go ahead and turn off the recording. If people have questions, I'm gonna stay on the Zoom for a while. But otherwise, we are done for today.